right, let's make sure this is working. Welcome YouTube, this is Beautiful Mind. Let me make sure this is working. Mic check, mic check. 1 2 1 2. I think it's working. I'm just trying to see my update. That reminds me. I kind of want to do one more thing. My students should know this by now. So, all right. So, welcome YouTube. This is Beautiful Mind. I'm not a fan of showing my image, but it is what it is. I am doing this for work, so you know. So, there has been. We decided to. We kind of had a meeting. I think it was like yesterday, and with after being forced to kind of go being forced to go online, and with all the difficulties of being live and all of that with YouTube and things of that nature, what we decided as faculty was that the following: that one, for attendance credit as students, you don't have to attend the live lecture. So I personally am still going to stream live on YouTube. You can be in attendance. If you have questions during the presentation, write them down. And you'd have to ask me during office hours, honestly. And so you'd have to look at the syllabus to see when my office hours are. And you'd have to ask me during office hours. But I'm totally fine with going live during class time, continuing that. I think that's healthy. It helps me to kind of honor the time and things of that nature. So I know I'm starting to maybe like 10 minutes early today. Let me look at my schedule. No, come on. Yeah, so we're starting like maybe 10 minutes early, but I'm still going to honor the length of time, so that way I can give myself a little bit of a cushion. So again, if you're one of my current students for any of my classes for this quarter, for spring of 2020, with the whole, light of everything that's going on, for attendance credit, we no longer have to be present for the live sessions. I'm going to record them. You watch them at your leisure. Take notes as if you're in class. If you have questions, you have to write them down, and you have to attend my office hours. I'll probably go live on Zoom during office hours, and I'll just kind of be sitting waiting. I'll be chilling, but if you have questions, that's a time where we can kind of come together and I can answer questions. Let me think. And so to actually get attendance credit, you have to submit at least one assignment every week. So our assignments are on Pearson. Let me see. Our assignments are on Pearson. If you're having trouble gaining access to Pearson, contact me. If you're my student, you should know how to email me. Also, you should have full access. I gave you all access codes to get full access. Okay, so if you're having trouble figuring that out, reach out to me. I think we had a quiz last week. Okay, so for the end of this week, let's be ready for exam 1. If this is support for college algebra, let's be ready for exam 1 over chapter 1. So today we're going to be starting chapter 2, section 2.1, combining like terms. But for this Friday, so towards the end of the week, anticipate exam 1 over chapter 1. I'll give you unlimited attempts until Saturday night at 11:59. So I'm offering a little bit of a cushion because I want you to kind of get acclimated to everything. Let me turn this up just a little bit. Okay, let's turn it down just a little. So yeah, I don't mind giving you that cushion. Just get your assignment. The main thing is just get your assignments. I'm talking so funny today. The main thing is get your assignments. Get your assignment submitted. I kept trying to say assignment submitted, and I kept switching the whole first letter. So I was saying assignments omitted. It's too early in the morning for me. Oh, I don't know about you all. I feel kind of weird about the next thing I'm about to say, but I low-key have been enjoying this whole quarantine thing. Like I like having, it's been one of my long time dreams to be able to teach from home. I'm assuming that the audio is okay. I'm getting red, but I'm assuming that it's okay. But yeah, I low-key have wanted to teach from home for a long time. I didn't want it to be like this, where everybody's in fear and all of that. That's totally not what I wanted. But I am grateful that I get to teach from home. So like if I'm tired, when I get off work, my bed is right on the other side of this camera. I just hop over there and I can get my rest. I'm not trying to. And be like, So I'm enjoying that. I've been running. That's been fantastic. I'm really enjoying that. And so that's like about 4 or 5 hours commuting that's saved. That's saving on time and gas. Those are like hot commodities. So, I could totally get used to this. Next, so that's phase one, is to be able to do my job remotely. Phase two is be someplace tropical where I want to be. So when I shut it down, I'm on the beach or wherever it is I want to be. But that's neither here nor there. So for our business, again, you do not have to attend the live lectures during class time, but you are responsible for watching the videos. I'll do my best to honor the time. Take notes as if you're in class. And to actually get attendance credit on a week to week, you have to submit at least one assignment on Pearson just to get attendance credit for the week. But that's just the starting line of this thing. Submitting one assignment, that's fine for attendance, but you want to get all of your assignments submitted for your credit. Okay, I can't think of anything else. So again, if you do have questions, just email me. My office hours are tomorrow. I'm going to let you kind of find that in the syllabus. But reach out to me if you have questions about anything. I will make you dedicated YouTube videos for any question that you throw at me from our material. Okay. It's very easy for me to do. It takes 5 minutes. Going live is a different thing. We'll go live if we need to, but a pre-recorded video is very easy for me to do. Okay. So normally I will pause for the cause at this moment, but since we're not live and I'm not really going back and forth with students right now, I'm going to go ahead and hop into today's lecture. Okay. So today we're going to be moving into chapter 2, and we're going to start. So again, our exam towards the end of the week is going to be just over chapter 1. So we finished that. I think we finished that on Monday. Okay. So we're going to keep moving. Today is Wednesday. So we're going to move into section 2.1, combining like terms. Okay. Now I am watching the live chat that's on YouTube. I'm monitoring that, so you can actually go into the live chat and type a question there, and I'll pause and respond to it that way. But trying to do the audio thing, going back and forth, was not working, and it was totally like mucking things up. But yeah, I am monitoring the live chat that's on YouTube. Okay. So if you have a question, you can type it there, and we'll do it that way. Okay. Yeah, let's keep going. So 2.1, combining like terms. I might go a little bit fast. So my intent for today, I want to go through about 4 sections, 2.1 through 2.4. So let's see how we're going to do this. Some objectives. We want to identify terms, identify like terms. We want to combine like terms, use the distributive property, remove parentheses when they are preceded by a plus or minus sign, and simplify an expression. Okay. Hopefully this is not overwhelming. I feel like the ideas or the concepts are simple. You just have to, the name of the game for this thing of mathematics is about pattern recognition. And the only way we're going to pick up the pattern recognition is to practice. Practice makes what? Absolutely not. If you said practice makes perfect, that's absolutely not. Practice makes improvement. If it was perfect, that means we would never have to practice anymore. And we all know what happens when we stop practicing. So practice makes improvement. One of my mentors, that's similar to how he would articulate it. So yeah, that's neither here nor there. Let's keep it going. So what do we mean by identifying terms? When an algebraic expression consists of several parts, the parts that are added are called terms of the expression. For instance, on the left-hand side, on this left-hand side here, we have the expression. Notice that there's no equal sign, so that's why we call this an algebraic expression. And the terms are things that are being added or subtracted. When an algebraic expression consists of several parts, the parts that are added are called terms, right? And keep in mind that subtraction is just another form of addition. We can always rewrite subtraction as addition, okay? So this first expression has 3 terms. This first term is added to the second term, added to the third term, okay? And there's also 3 terms in the second expression. Okay. So again, if you have a question, you have to write it down and reach out to me outside of, honestly, if you want to reach out to me during this time, you'd have to go in the live chat on my YouTube. Otherwise, attend my office hours and we'll link up. Okay. So numerical coefficients. The numerical factor of a term is called the numerical coefficient, or simply its coefficient. So for instance, this term here we have on the left, this negative 8y, the numerical coefficient is just the negative 8, the number in front. Here, the term, okay, so we have 6 times this thing. Let me see, so the numerical coefficient is just the 6. Now, what I would do with something like this, I would actually distribute this 6. I would get 6x minus 12. and then the numerical coefficient would be the 6. But, you know, anyway, let's keep it moving. We're going to need some air. That was strange. I don't know how that happened. I don't even know where that came from. All right. So, moving along. Does this come out? Okay. So what do we mean by like terms? So like terms are terms that have the same variable with the same exponent. So for instance, over here on the left, we have 6y and negative 2y. Notice that the variables are the same and the exponents are the same. So we call those like terms, okay? We call these like terms. They have the same variable and they have the same exponent. These are also like terms, right? These are the same as like 9 times x to the power of 0 or 2 times x to the power of 0. These are constants. So these are like terms. Unlike terms, notice here on the right, the first variable is x, but this other one doesn't have a variable, right? So these are unlike terms. We can't add these. These are unlike terms. Even though they're both y, the exponent on this first y is a 1. The exponent on the second y is 2. So here, when there's no number written, there's an implied 1. Okay, I'm going to keep moving. So example 1, we're asked to identify, I didn't want to see the answers. Okay, I didn't really like how that one displayed. I would have rather had the question and then the answers on the second page. Okay, I think I have a workaround. Since this one is showing, I'm going to let that be. And before I go to the next slide, what I'm going to do, I wish I had a preview. I can look at it. Give me just a moment. I'll be right back. Okay, so I'm going to leave that last slide as an exercise because the answers we're showing. If anything is not clear, just reach out to me and ask me, okay? And I can go into further details. So next, we want to talk about combining like terms. To combine like terms, determine which terms are like terms, and then add or subtract the coefficients of the like terms, and then multiply the numbers found in step 2 by common variables. Okay, so let's see this in action. Let me see. I think we might have an example next. I feel like it's straightforward. Or we can do it this way. So we're asked to combine like terms. We have this 8x plus x plus 2. I'll pause for like 30 seconds just so you can give it a go for yourself. So I'm going to pause. If we have 8x plus x plus 2, give it a go yourself and see how it works out for you. Okay. So what are the like terms here? Well, the like terms in this case are going to be the 8x plus 1x is going to give us 9x, and then that's it. So then the answer should be 9x plus 2. Okay. Let's see, what do we have next? Okay, here we're asked to combine like terms again at the bottom of the screen. All right. So we have a 3b. Notice there's no other b, so this is an unlike term. We have a 6a and this negative 4a. Those are going to add up to give us a positive 2a. And then the negative 1 is also an unlike term. So then the final answer is going to be 3b plus 2a, or 3b plus 2a minus 1. Okay. 3b plus 2a minus 1. Okay. Again, if you have questions, you have to write it down and attend my office hours to engage. You can or you can type your question in the live chat. Okay. So the next idea or notion is using the distributive property. So we want to talk about subtraction of real numbers. For any real numbers a and b, keep in mind that subtraction, a minus b, can be rewritten as addition. So a minus b is the same as a plus negative b, right? So whenever we subtract, we can rewrite addition. So a minus b is the same as a plus negative b. Distributive property. Say we have multiplication over addition. If we distribute, right, a times b plus a plus c, we get this. So this is multiplication over addition. Okay. Okay, let's look at this example. All right. This 10a asks us to use the distributive property to remove the parentheses. Oh, we got the answer showing. So I'm going to have to leave these as an exercise as well. So keep in mind, these examples should parallel what's in the homework, all right? So we can do our homework, and also with Pearson, they explain how to do each question. So I'm going to let these be. Let's try another one. This is the same kind of deal going on. So the solutions are already shown. I could open this up, but I'm just going to go with it for now. I'm not going to worry about it. Again, if anything is not clear, just reach out and we can talk about it. Okay. Now, in this first example here, since there's nothing to distribute, we can actually just lose the parentheses. In the second example, we have, again, multiplication over addition. So we're actually going to distribute a -1. So we're going to say each of these terms multiplied by -1. All right, and we get this result here. Okay. Let's see what else we got. All right, so to simplify an expression, use the distributive property to remove any parentheses and then combine like terms. Let's see, what do we have? Awesome, we don't have the answer for this one. So since this answer is not showing, I'm going to work this one out. So let me start by getting a copy. And I'm going to cut that. I don't need that, nor do I need that. Okay. And we're going to work this one from scratch. Okay. All right. So we have this. We're asked to simplify. I just like the line paper. Hopefully it's not too jarring on the eyes, but it helps me to write better. Okay. So simplify. I like to start by getting a copy of the original. We have this -2/3x minus 1/4 plus 3x. Okay. So notice this says to simplify, right? And notice there's no equal sign. So when there's no equal sign, this is called an algebraic expression, and that means we can simplify it. We can't solve it. We should not get something like x equals 2 or whatever, but we can simplify it. Now sometimes the variables do cancel, and that has a meaning, but we can simplify something of this nature. Okay. So let me pause. I'll take a break. I'll pause for 1 minute and see how you can do on your own. Can you solve this, simplify this expression. You can pause the video, work it yourself, and see can you get it going, get an answer, and then see if you get the same thing as me. So I'll pause for a second. This is a good time to pause your video and test it yourself. And then when you're done, you can press play again. All right, so let's see how this one has worked. Okay. So now, when I first see this one, the first thing I would do, I see we have distributive property, right? So we have multiplication over addition. So we can distribute this negative, right? I'm going to say this is the distributive property. Okay. So if we distribute, we'll get -2/3 x plus 1/4 plus 3x. Okay. And the first line should equal the second line. Okay. So the next thing I'm going to do, I'm going to combine like terms. Combine like terms. Okay. So what are our like terms? Our like terms are going to be this one because they have the same variable with the same exponent, and then it's 3x. Style. Those are our like terms. Okay, so basically what we want to do is say a -2/3 plus 3. All right, so we get the following thing going on. So now, this -2/3 plus 3 is 1/4 is our unlike term. So now this is a discussion of adding and subtracting fractions. This is a good time to pause pause the video after this question to make sure that you're thinking properly. How do we add fractions? We have to get a common what? Okay, so we should have to get a common denominator. So we need to add fractions. The next thing we want to do is add fractions. Also, if you are watching this video, if you're one of my current students, I'll make a PDF version of anything, all the stuff that you see me writing. I'll make a PDF available for your records. Okay. So now to add fractions, we get a common least common denominator or least common multiple, right? So we want a common denominator. So we're going to say this plus this. This comes down. So now one denominator is 3. The other denominator is a 1. The common denominator between those two, the least common multiple, is going to be, we can get them both to be 3. All right. So that means this first one stays as is. So this second one, we want to rewrite it. So keep in mind that this second one is over 1. So what could we multiply this by? What form of 1 could we multiply so that the denominator becomes 3? We're going to multiply by 1 in the form of 3 over 3. So that means we'll finish with 9 over 3. Does that make sense? Because 9 divided by 3 is 3, right? Okay. And our x needs to persist. Okay. So then, to add fractions, once we have a common denominator, we just add the numerators. I'm just being a little OCD. Anyway, it's the time we started at 10:50, so we got about, no, that's not right. Yeah, we got a little bit of time. Okay. So now that we have a common denominator, we just add the numerators. So -2 plus 9 is going to be 7. So this is going to be 7 divided by 3x plus 1 by 4. This was the final answer that I got. Okay. All right, let's go to paper. Let's turn this off. Okay. So, the final answer that I got was 7 over 3x plus 1 by 4. So I'm going to check now something like this. And then let me just go ahead and make this note. Paper. I think it's fine. Yeah. So we got 7/3 x plus 1 by 4 and 7/3 x plus 1 by 4. You see it here. Okay. So again, if you do decide to attend live, that's fine. It's your prerogative. If you are in attendance live, if you have any questions, keep in mind I am monitoring the live chat. Okay, let's keep it moving. Okay, we're asked to simplify. Let's do another one. Okay, let's do another. So I'm going to start by getting a copy of the original and pretty much just repeat the same thing again. So here is a copy of the original. That's there. That's there. Okay, like that. And then this goes here. And oh, there we are. So we want to add a page. All right. Come on. All right. So let's give this one a go. We're asked to simplify. Now, again, I'm a fan of writing on my lines. I don't know what that's about. I just like it, so I like to use it. And also, I like to start by having a copy of the original. So the original, we have this 3 times 2a minus 5 minus 3 times b minus 6 minus 4a. All right? So this is a copy of the original. So now, at first glance, the first thing I notice, I'm going to do green this time. Let's distribute. It looks like we have a lot of distributing going on. So again, also, it is a good idea. This is a good time to pause the video. Maybe try working this one yourself and see how far can you make it. Can you simplify it all the way down to the end on your own? The more you're able to do that on your own, the better. If you're not, it's okay. If you're not able to do it on your own right now, it's okay. Even if, honestly, it's going to be okay no matter what. But, don't be afraid. Just give it a go. Give it a go. Okay. So this is a good time to pause the video, try it yourself, take it as far as you can, and then compare at the end. Okay. So you had to forgive me. I had to take a bite. The apple was so delicious. I mean, I think it's like a Honeycrisp apple. I don't know. It's yummy. Anyway, that's neither here nor there. Oh, shout outs to Infinite Waters, Ralph Smart. I definitely listen to that brother like a lot. Like, he is fantastic. He's always promoting like the 7-day vegan fast, and he's one of the people that inspired me to be able to at least get on YouTube and do this kind of stuff. You can see like his videos from where he started, where every day he would get out in nature and breathing in that good ass prana and stuff like that. But yeah, I just brought him up because I bit the apple, and so him always talking about being vegetarian and vegan encourages me to do it. Not that I'm a nutritionist or I'm authority to say anything about it, but I do appreciate the videos that he posts. His name is Infinite Waters Ralph Smart. Hopefully he doesn't mind that shout out. Okay, so let's give this example a go. So let's simplify. So let's distribute. So we can distribute the 3. We can distribute the -3. And that's it, right? So let's account. So the first thing we did was we distributed. Okay. So if we distribute, the first one is going to become what? 6a minus 15. We're going to get minus 3b. Double negative is positive. 6 times 3 is 18 minus 4a. Okay. Next, what we'd like to do is combine like terms. Combine like terms. Sorry, I am being just a little bit OCD right now. All right, that's neither here nor there. Okay. So next we want to combine like terms. So what are our like terms? We have a 6a. We have what, a 6a, and we have a -4a. So let's style. Let's do this color. So those are like terms. Another set of like terms, we got this -15 and this +18. There's another set of like terms, right? So then if we combine those like terms, we'll get the following. 6a minus 4a is 2a. The -3b just comes down because it's an unlike term. And then -15 plus 18 is a +3. And then this is the final result. So normally I would be like, are there any questions? But again, we're not really going back and forth. We had to change our structure. So I get this result. Okay, let's see, how do we do? Let's go to paper and put it back here. Okay, let's see, how do we do? 2a minus 3b plus 3. 2a minus 3b plus 3. Hey, you got to celebrate the little stuff. It's like it's so much dark and scary things out there. You got to celebrate whenever you can, because it's enough things out here just trying to bring us down. Got to celebrate. It just makes it fun. Anyway, we got it right. Yay. Okay. All right, moving along. 2a minus 3b plus 3. Okay. So again, if any of that was not clear, just reach out to me and we can talk about it. We can get on the phone and, do all that kind of stuff. Moving along. Okay, so that actually ends section 2.1. So the time, that took about 30 minutes, which is about right. Give me just a moment. I'll be right back. Give me a second. Hey Siri, I need to walk Malachite. I need to walk Malachite. Okay, YouTube, we are back. So I had a special guest visitor. I offered to a friend to do some Oh, what you're seeing here is actually on the TV screen. It's a little bit of a delay, but you can actually listen and watch there. It's the same. Um, I'm still just kind of talking for right now, though. But I am trying to make sure that the audio is working properly. Let me see. Hey Google, increase the volume of the basement TV. How come I'm not hearing anything? Let's see. What else could I do? Okay. Okay, YouTube, we are back. So I had a special guest visitor. Hey Google, mute the volume of the basement TV. Oh, what you're seeing here is actually on the TV screen. It's a little bit of okay. So yeah, I made a quick little setup so that I have actually I'm just gonna say Mr. Logan, okay? Or we go by Logan. You want to go by Logan or Wolverine? You want to go by Wolverine? You're not Wolverine. But his name is Logan. So I have a guest here. How old are you, Mr. Logan? 8. You said Mr. Wolverine. I would call you Mr. Wolverine. So we have Mr. Wolverine here. He's 8. Okay. So but I thought it would be good that he can actually do this information. So let me see if we got about class ends at 11. We still got about an hour and 20 minutes remaining. So we just wrapped up. Let's get back to the lecture. All right, YouTube, we are back. So we just wrapped up section 2.1. We do have a special guest. I'm going to call him Mr. Wolverine. So I'm not going to show any images, but I offered to a friend. Mr. Wolverine, how old are you?
8.
Mr. Wolverine is 8. So we're going to see if you are smarter than an 8th grader. No, an 8-year-old. Excuse me, not an 8th grader, an 8-year-old. So, but yeah, he's going to be joining us. So we have a TA with Malachi. Malachi can come here. She's taken now because she got some attention. She got somebody else to play with, so she don't want to come. So she's in hog heaven because she got attention. But yeah, he's going to be joining us, and so I'll probably be asking him questions and seeing if he can do it. Because I feel like if he can do it, then we can't make excuses as adults, right? If I have an 8-year-old that can do this, we can't make excuses. So we're going to see. We're going to see. Hopefully we don't get embarrassed here. Okay. This is kind of cool. We got a nice little system going. All right. So let me do a mic check one more time really quickly. Hey, Google, change the volume of the basement TV to 30%. Hey, Malachi can come here. Okay. Hey, Google, mute the volume of the basement TV. She got some attention. She got somebody else to play with, so she don't want to come. Sorry. So she's in hard heaven. Hey, Google. Mute the volume of the basement TV. And so I'll probably be asking him questions and seeing if he can do it. Okay, good, because that was totally loud. So it does work, but I know it's going to clash because the audio from the TV will come on the mic, and that'll just be pandemonium. But anyway, so let's get back to it. So yeah, Mr. Wolverine, you can actually watch on the TV screen. So this actually helps. I can see what other people see, but then you'll get a live session. So now today's date, go ahead and write down. Let me see. Today is March the 25th. So you got the date, you have your name. This is chapter 2. I don't have a book handy. I might have a book somewhere. What is chapter 2 on? Well, this is section. Okay, so we're going to move into section 2.1. Let me go back to the top here. It's actually on the screen there on to your right. Chapter 2 is on solving linear equations and inequalities, Mr. Wolverine. Okay, I'm gonna let him do his thing. So we're on chapter 2, solving linear equations and inequality. We just finished out section 2.1, combining like terms. Okay, and we're actually going to move into section 2.2, the addition property of equality. So when it shows on the screen, it will be a little bit of a delay because it's going out into the internet. It's going out into space, into the internet. Like I'm streaming live on YouTube. And then it's coming back from space and the satellites back to my phone, and then I'm going to AirPlay it for the phone. So it is going to be a delay, but eventually you will see on the screen what I'm writing. So you could either listen or write. The delay is about 30 seconds. It is a pretty good delay, but let's keep going. I guess if you want to watch here, you can. Nope, because I guess what I could do instead, hopefully this doesn't mess it up. Let me try one other thing. Let me go like this, and I want to mirror the screen to this basement TV. Hopefully it doesn't mess up. It probably will, but is it gonna work? I just want to mirror the screen so it can be live. Mirror, yeah, I just want to mirror it. And I want to optimize, come on. Oh, come on. No, I got to put that back. And I want to optimize this for my laptop, not the TV. Built-in retina display. Okay, I think this will work. Or, I'm sorry, I'm totally getting fancy here. I'm gonna do one other thing. Use as a separate display. And I want this guy. I want this one. There it is. Because this is the one that hopefully that'll work properly. All right, so that's, let me see. Okay, I knew I was gonna do something like that. So then, give me just a moment. I'll be right with you all. Browser screen capture. This one, and I just want to, yeah, let me just adjust it. No, you know what? For the sake of simplicity, let me put it back. Mirror this. Let me go back here. Okay. And I want this to be best for the laptop. All right. And I think we're back. It looks good. And come on. You're supposed to be mirroring. There we go. So I know it's a little bit of extra stuff. Let me see if I can kind of clean that up a little bit. If I can get that to go away. There we go. Okay. So Mr. Wolverine, now you can see live. So now as I kind of go through, you basically can see what I see on my screen, right? Okay. Sorry about that. Yeah, so I did something on the fly. We're still good on time, so let's kind of keep it moving. So this is going to be, we're moving into section 2.2, the addition property of equality. Okay, so if you wanted to write the title of this section, it's a good idea to write 2.2, the addition property of equality. Malachi, oh yeah, she's fine. Okay. I guess she would be the Green Lantern if you're Wolverine, but those are different universes, so maybe not. So some objectives here is to identify linear equations, check solutions to equations, identify equivalent equations. It's on the yeah. Use it. You don't have to write all this. So I'll show you what to write. You can just listen for right now. Does that make sense, Mr. Wolverine? Yeah, because I know that's going to be a lot to try to write. Use the addition property to solve equations and solve equations by doing some steps mentally. Okay, let's see this first one. Mr. Wolverine, do you mind reading this for me? What you see on the screen? Come on. Pardon? Yeah, it's the same.
Linear equation. A linear equation.
Linear.
A linear equation is
in
one of
variable.
Is an equation that can be written in the form ax plus b equals c, where a, b, and c are real numbers. A 0.
Not equal to 0, right? That's that symbol. Like, yeah, this symbol right here, that's not equal to 0. Yeah, it's an equal sign with a slash through it. High five. That was fantastic. All right. So, let's see. A linear equation in one variable. A linear equation in one variable is an equation that can be written in the form ax plus b equal to c, where a, b, and c are real numbers, and a is not 0. For my students, this may look familiar or similar to y equals mx plus b. All right, so it is similar to y equals mx plus b. You had a question? You're okay? You okay? Okay. So the solution of equation, Mr. Wolverine. What's the solution of an equation? Like if you have an equation, just in your own words, what does it mean for it to be a solution? What does that mean?
What it means to be a solution is,
like say you have an equation and you get something like x equals 2. What does that mean?
I would think that means that I would think it really hard and I thought about it before I put the answer down.
Okay, I get down with that. Let's see how it evolves. So this one says the solution to an equation is going to be the number of numbers that, when substituted for the variable or variables, makes the equation a true statement. So let's see what that means. I think this is easier to see if we see it in action. All right. So this example says, consider the equation 2x minus 4 equals 6. And then it says determine whether negative 3 is a solution. So if we have 2x minus 4 equals 6, if we want to know if negative 3 is a solution, what do you think we should do with that? What does that mean? All right. So what this means, Mr. Logan, if you could do like write down 2x minus 4 equals 6.
Mm-hmm.
This is example 1. And you want to write 2x minus 4 equals 6. So if is negative 3 an answer to this equation? How could you tell? How could you tell if this was an answer or not? Maybe if we like plug it in, right? If we plug in if we were plugging in the negative 3 for x, see, does it work? For instance, Mr. Wolverine, what's 2 times negative 3? Or what's 2 times 3?
2 times 3 equals 6.
6, right?
Yeah.
And then, so that's going to, can you tell me if we did negative 6 plus negative 4? Can you tell me that answer? So let me see, a negative 6. Let me see. Okay, so I don't know how to let me see this one. So let's do it this way. We have 2x minus 4 equals 6. If we plug in the negative 3, we're going to get 2 times negative 3 minus 4 equals 6. All right, and this is a question, so we don't know if this is true or not. So then we get negative 6 minus 4 equals 6. And we finish with negative 10 equals 6. Is this true or is this false? Is negative 10 equal to 6? Which is more? Say you had $60 in your account or you had negative $100 in your account. Which would you rather have, $60 or the negative 100?
The $60.
Right, you'd rather have the $60, right? So is $60 the same as negative $100?
No.
So is 6 the same as negative 10?
No.
Exactly, right? So these are not equal. This is a false statement, right?
Yeah.
So because this statement is false, back to our original question, is negative 3 a solution of this equation?
No.
Right, it's the same answer, right? So because when we plug in the negative 3 into the original, it gave us a false statement. So then negative 3 is not a solution, right? And we can see it here. Let me get a copy of the work that we did. We're going to put it here like this. All right. So, and we'll do our work in like Mr. Wolverine, what's your favorite color?
Blue.
Blue. Okay. I get down with blue. So we'll do our work in blue, and we'll see that since we finished with the false statement, negative 3 is not a solution. It's not a solution of the original. Okay, let me see the time. I think we're okay. All right, let's move forward. So, Mr. Wolverine, keep in mind, I'll give you a copy. I'll give you a copy of this, so you don't have to write everything. I just need you to kind of go back and forth with me with the questions. Let's give another one a go. So we want to identify equivalent equations Let's see, to solve an equation, this means to determine the solution. To solve an equation, we will make use of two properties, the addition property of equality and the multiplication property of equality. We use these properties to obtain an equation in which the variable is alone on one side of the equation. When we attain such an equation, we have isolated the variable. Okay. So as we kind of work through these equations, we're going to have a left side of the equation and a right side of the equation. Okay. I think first we're going to solve where the variable's on one side of the equation. Okay, let's give it a go. Mr. Wolverine, do you mind reading this for me?
Addition property of equality.
Mm-hmm.
If A equals B, then
I'm recording, so I'm about that too much. All right. Ooh. Okay, so I can hear. I'm just gonna keep moving. It looks like it's kind of lagging a little bit, but I'm just gonna keep moving. So what this slide is saying, it says the addition property of equality. So if we have an expression on the left equal to an expression on the right, then what this is saying is that we can add the same real number on both sides of the equal sign, and preserve equality. Okay. So this next example, what would you do to solve that? I'm just x. Can you tell me what's the opposite of -4?
that it's what's the opposite of -4 is that
What's the opposite of negative?
that
The other one.
that's not positive.
To both sides, right? We're going to do the inverse operation. A number plus its opposite. It looks like my stream health is not doing well. We got about little less than. We should know that one.
-4.
Let's try another one. We'll get another one going. Let's see. -2. All right. Can you? So what would you do, Mr. Wolverine? What would you do to get the x by itself?
I'll probably think of what the place of the x would be, and then
Okay, I see.
probably like get a number problem and like what we did on the top one.
Okay.
It said
Okay. Let's see. So this one, if we want to isolate the x and we have that -2, if we have that -2, what's the opposite of -2? What's the opposite of negative?
That it's not positive.
So the opposite of -2 is +2, right? So what we're going to do, we're going to add 2. We're going to say +2 on both sides of the equal sign. So +2 and +2, right? A number plus its opposite, these add up to 0. 2 plus -9 is going to be -7. All right, so that one results into -7. Okay, that's fantastic. Okay, let's do another one. Solving equations by doing some steps mentally. So with this slide, let's say the time. So it says when we feel comfortable using the addition property of equality, we can wish to do some of the steps mentally to reduce some of the written work. For example, this problem may be shortened as follows. So where we wrote out, add the 5 on both sides, and then you got 12 plus 5, and then 12 plus 5 is 17. You see the shortened form on the right-hand side, all right? We're going to let that be for right now. But did that? Okay, that actually closed out 2.2. That was the end of 2.2. So that was the addition property of equality. Let's go ahead and move into the next section, which is 2.3. So we're going to continue chapter 2. Solving linear equations and inequalities. And we're going to move into section 2.3, the multiplication property of equality. The multiplication property of equality. Okay. So some objectives. We want to identify reciprocals. We want to use the multiplication property to solve equations. We want to solve equations of the form negative x equals a. We want to do some steps mentally when solving equations. Okay. So the first thing we want to do is identify reciprocals. Recall that two numbers are reciprocals of each other when their product is 1. Mr. Wolverine, can you tell me what is a product? What do we mean by product? What does the word product mean? No?
Like in second grade we learned about them. It said that if you get, it's like if you have a number sentence and you have a factor and then a factor and then a product, you get with both of the factors.
Right.
The two numbers, and then you get a total, and that's a product.
Exactly. So that was fantastic. High five. That was awesome. So a product, you're going to take two factors. We got our other TA, so there's a lot going on. Our other TA, the Green Lantern, aka Malachite, she loves attention, so she has somebody new here, so she's just like super geeked. So she's just trying to like hog all the attention. She doesn't know how not to have the attention. But yeah, product are things that we multiply. So factors are things that we multiply to produce a product, right? Terms are things that we add and subtract to produce a sum. So for instance, if we say take the number 5, its reciprocal is going to be 1 over 5. And if we take the product of 5 and 1 over 5, we get 1. Right? So a number times its reciprocal is going to give us 1. Okay, we're going to let this be. Mr. Wolverine, can you tell me what is a reciprocal in your own words? So if you see the 5, the reciprocal of 5 is 1 over 5. What'd you say?
A fraction.
Right. So we essentially flipped it, and it essentially became a fraction, right? So if we have 5 over 1, when we flip it, we flipped it upside down and became the fraction 1 over 5. So on and so on, right?
We learned about that in second grade too.
Okay.
We learned that if you have like a number like a third, a fourth, a first, or a whole, I think that was the one, and then you have a second, and when you put a lot under it, then you put the number, and that will mean like 1 whole of a fifth, I think.
Exactly.
Or like 1 second of a fifth.
Right. Like these are parts of a whole, right? So like for instance, like look at this number. So we have the 1 over 5 on the screen. So the 1 over 5, this fraction is part of a whole. Like you have 5 parts to make the whole, and we have 1 of the 5. Right? So we have part of the whole. Yeah, this is pretty good. Let's keep it going. So I think we have like 15 minutes remaining, which is more than enough time. So let's kind of keep going. So then we have, let me see if this will work. Okay. We have the multiplication property of equality. So given that two expressions equal to each other, A and B, so A equals B, we can multiply the same, it should be non-zero real number on both sides of the equal sign and preserve equality. So if we have A equals B, then A times C is going to equal to B times C for any real numbers A, B, and C. I guess if we lead with the premise that A equals B, then yeah, C could be 0. I mean, it holds for 0, but the whole 0 thing kind of does throw a little bit of monkey wrench in it. Okay, let's give this here. We have another example. So this one asks us to solve 6x equals 54. So if we have 6 times x equals 54, if we want to move that 6 to the other side, what's the inverse operation of multiplication? What's the opposite of multiplication? Division, right? So if we want to move the 6 to the other side, we want to use the inverse operation. So since we have 6 times x, to move it, we're going to divide both sides. So we're going to divide both sides by 6. Mr. Wolverine, can you tell me 54 divided by 6? Did y'all do your division in class? You know how to do division?
No, not yet.
Have you done long division?
No, not yet.
For instance, like So like if we did 6 divided into 54, does that look familiar?
No, but I only know one, and it's 36 divided by 6.
Is what?
6.
That's right. That's fantastic. Let me see. How many 6s are in 5? Here, let's do it like this. So the 5 is too small for the 6, right? What's so we're trying to figure out 6 times what gives us 54. Can you tell me 6 times what to give us 54? So what's 6 times 6?
36.
What's 6 times 7?
42.
42. Can you tell me 6 times 8?
48.
48 sounds good. Can you tell me 6 times 9?
54.
54. That's the number that we wanted, right? So we do need to know our times tables. That is important. So if we divide both sides by 6, we should get x equals 9. Boom, and you see it there. Fist bump, you did a great job. All right. So, let me see. Let's move forward. That was good. Solve the equation 2/3 x equals 6. Okay, so again, we want to do the inverse operation. So if we have 2/3 times x, what's the inverse operation of multiplication? What's the opposite of multiplication?
Division.
Division, right? So if we divide both sides by 2/3, then really we're multiplying by the reciprocal. Can you tell me the reciprocal of 2/3? If we, can you tell me the reciprocal of 2/3?
So it's like equaling numbers?
So reciprocal just means flip it, right? So instead of it being 2/3, we're going to get 3/2. Right? So if we divide both sides by 2/3, that's the same as multiplying both sides by the reciprocal. Right? I meant to work this one out, but that's okay. So I know you might not be able to get all this, and it's okay if you're not able to write it. It's okay. Solve this equation. This one we have -48 equals 6 times x. So if we want to isolate the x, and we want to move the 6 to the other side, if we have 6 times x, what's the inverse operation for 6 times x? What's the inverse operation of multiplication? What's the opposite of multiplication?
Division.
Division, right? So if we have 6 times x, then the inverse operation, we're going to divide both sides by 6. Can you tell me what number times 6 gives you 48?
8.
You did that way faster than I thought you were going to do that.
We have finger number songs. We have finger number songs in class.
You said finger numbers?
Yes, like you add them up on your fingers. Like
Okay.
we have 4s through 12.
Okay. So do you know you ever done the human calculator trick? You know the thing with the 9s? You ever done that one?
No, not yet.
What's your favorite number 1 to 10?
8.
8, right? So if 8 is your favorite number 1 to 10, can you tell me 9 times 8?
17.
Okay, look. So for the 9s, look at this. You have to look at my hands. So for the 9s, we said 9 times 8, right? You said it was what, 72?
Yes.
1, 2, 3, 4, 5, 6, 7, 8. What did you say 9 times 8 was again?
72.
72. You see it?
Yeah.
You drop the 8 finger and we get 72. Give me another number 1 to 10.
9.
Okay, what's 9 times 9?
81.
So if we drop the 9, 1, 2, 3, 4, 5, 6, 7, 8. If we drop the 9, what's 9 times 9 times 9?
81.
81. Right? And you probably have to look at it backwards because I think for you guys, but from my view, it looks like this. 81. Give me another number 1 to 10. 6. What's 9 times 6?
54.
So look, Mr. Wolverine. So look, if we drop the 6 finger, this is the 6 finger right here. You said it was 54. Yeah. 54, right? So that's a trick I got off of YouTube. It's called like the human calculator. It works for the 9s, and you can actually go beyond 10. That actually gets into a little bit of number theory, right? So you can drop that finger, and it's actually showing you the digits, as you kind of do those things. So, long story short, I think we said 8 times 6 was 48. So then I think that answer is going to be -8. You see it here. Okay. So again, if you are watching or if you're listening or if you have questions, reach out to me and I'll make sure to make a dedicated video walking you through any of the questions. So with this example, we have -x equals -13. This is the same as -1 equals -13. Or -1 times x equals -13. So if we want to move the negative to the other side, we need to use the inverse operation. What's the opposite of multiplication?
Division.
Division. So if we want to move the -1, we can divide both sides by -1. Logan, Mr. Wolverine, if I say double negative, what's the response? Double negative becomes what?
Positive.
Positive, right? So if we say a negative divided by a negative, the final answer is going to be positive, and we're going to get x equals 13. Okay, we're going to let that be. Solve the equation. So in this next example, we have -3 times t equals -21. Mr. Wolverine, can you tell me the answer here? What would you do? When you look at this, what would you do? Anything comes to your mind as far as how to solve this?
It said solve the equation -3t equals -21. I would probably.
So we have the -3 times t. What's the inverse operation for multiplication? What's the opposite of multiplication?
Division.
We're going to divide both sides by what number? What do you think?
-2? I mean -3?
Yeah, right? So if we divide both sides by -3, can you tell me 21 divided by 3?
21 divided by 3.
Or in other words, what times 3 gives you 21?
Seven. 7 times 3 equals 21.
7 is correct. Okay. Let's see the time. We've got about 30 to 40 minutes. We're almost done. So I'll probably stop once I reach the end of the slides. And if there's any remaining time, we can actually do practice sets. The main thing is I just wanted to get through these sections for today. Be sure to do the assignments on Pearson and reach out to me if you have questions, okay? If anything is not clear. These are for my students that are out there. Okay, in this example 12, it says solve the equation 1/5 x. Okay, so for the sake of time, I'm going to kind of go through these a little bit quickly. So the inverse operation is division. If we divide both sides by 1/5, that's the same as multiplying by the reciprocal. Mr. Wolverine, can you tell me 5 times 20? What's 5 times 2?
10.
10, right? So can you tell me 5 times 20? So if 5 times...
I think it's 100.
It's right. That's right, right? So if 5 times 2 is 10, then that means 5 times 20 is going to be the same answer. You just add on a 0 because there's only one extra 0, right? So instead of 10, it was 100. All right. So we multiply both sides by 5. Again, we're doing the opposites. All right. We're going to let that be. So that actually closed out section 2.3. And we're going to go ahead and move into the final section for today for this course. So this is, I want to say that this is the last that we're responsible for. I'm not going to put this on exam 1. Exam 1 is just going to be just chapter 1. I think we did sections 1.3 to 1.8. That's exam 1. And this is, I think for right now, this will be the last section that we do in chapter 2. Okay. So we're going to move into section 2.4, linear equations with only one, with a variable on only one side of the equation. Okay. So some objectives. Mr. Wolverine, do you mind reading that for me?
Okay. So objectives. 1. Solve linear equations with a variable on only one side of the equation.
Awesome. Keep going.
2. Solve equations containing
Decimals,
decimal numbers, or fractions.
Okay, that was good. Sorry, I'm just like munching all in the mic. I mean that to just kind of keep myself awake. I'm totally sleeping, and I'm a little hungry, so I figured I get a little boost from eating the apple. Anyway, let's keep it moving. So let's see. To solve linear equations with a variable on only one side of the equation, if the equation contains fractions, multiply both sides of the equation by the least common denominator. This is going to eliminate the fractions from the equation. Then use the distributive property, combine like terms, use the addition property to isolate the variables, use the multiplication property, and then check your answer into the original. Oh, okay, I don't want to see these answers. So let's work this one out. Let's give this one a go. We're almost done. Let's get a copy of the original. We're asked to solve this equation. So I'm going to drop a copy right there. And let's add a page. Okay. Okay. So we're asked to solve this equation. So let's see. I usually like to write on grid paper like this. And I also like to start with a copy of the original. So we have this 7x minus 5 equals 30, right?
7 times negative 5 equals 30.
7x. X is a variable or unknown, so this is 7x minus 5 equals 30. So we want to move some of these terms and coefficients. We want to move these numbers away from our variable, right? So if we're going to move that 5 first, if we're going to move the 5, if we have minus 5, what's the inverse operation? What's the opposite of negative 5? What's the opposite of negative 5?
Positive 5.
Positive 5, right? So we're going to add 5. We're going to add 5 to both sides. What's your favorite color? Or in other words, what color are you feeling right now?
Pink.
Pink, okay. So we're going to add 5 to both sides of the equation. All right? So if we do this, a number plus its opposite adds to 0. I'm going to... Not that one. What's 30 plus 5?
35.
30 plus 5 is 35. That's going to be a 0, and the 7x comes down. So now we have 7x equals 35. So if we have 7 times x, what's the opposite of multiplication again? Division. So if we divide both sides by 7, If we divide both sides by 7, x is going to be equal to, what times 7 gives you 35?
5.
7 times 5 is indeed 35. So 35 divided by 7 is going to be 5. We get this answer. Oh, we get this answer. Okay. Style. Okay. Now, if we get an answer like this, we want to make sure. So the following is what made one of the things that made me fall in love with math. I remember just being younger, high school, and even in college, and even in grad school. Well, grad school not so much, but definitely in high school and college. I remember being in like literature class. I would do all the things that the teachers would say. I would read the books, write the reports. I would be stressing myself out, and then they would look at it and they'd be like, "Meh, C, B." I was like, "What? I did everything you said. I read it. I wrote the report." It was like, "That's not what they mean." I was like, "How am I supposed to know what they mean?" Obviously, I feel some kind of way about this, but I felt like they were just giving me grades just to kind of mess with me. But in my math classes, I would get an answer and I would ask myself, okay, if x equals 5, if that's the answer, does that make sense? Does that make sense in the context of the original? So I would check my work, and the ability to check our work, even when I had professors that didn't like what I was doing, they had to give me my points. And so when I realized that mathematics was empowering me, I fell in love with it, and it's never stopped. So let's check our work by plugging this 5 back into the original. We have 7 times 5 minus 5. The question is, does that equal 30? Mr. Wolverine, can you tell me 7 times 5?
35.
7 times 5 is 35. What's 35 minus 5?
30.
35 minus 5 is indeed 30. Is this a true statement or is this a false statement? Is 30 equal to 30?
It's true.
That's true. This is true, right? True. So that's what we want. So we can stand by the answer of x equals 5. Okay. See the time. Ooh, I don't know if anybody does numerology. We are approaching an auspicious time. It's almost 11:11. Okay, so we got an answer of x equals 5. We're going to stand by that answer. Let's see it worked out. And they get the same answer. Okay. And we checked it as well. We got a true statement. We might have one, maybe two more examples. Let's give this one a go. Let's start by getting a copy of the original. I'm going to make some space right here. And let's give it a go. Come on. All right. Let's give this one a go. So we're asked to solve the equation. We have this 16 equals 4x plus 6 minus 2x. I usually like to do paper. I like to do grid paper. And let's get a copy of the original. We have 16 equals 4x plus 6 minus 2x. Okay, I usually like to do this bar just to kind of make it clear what's the left versus what's the right. So to solve something of this, first thing we want to do, let's combine like terms. All right, let's go ahead and combine. Mr. Wolverine, did you have a question?
No.
Okay, let's combine like terms. All right. Mr. Wolverine, you see that line going up and down, the one that's a little bit darker?
Yeah.
So if you look on the right-hand side of that line, can you identify which ones are the like terms, like which ones are similar?
I think that's similar.
Okay, I see what you're getting at. Let's do like this, right? So we're gonna say that the ones in purple are what we call like terms, because they have the same variable with the same exponent. I know that's like not gonna make sense right now, but the ones in purple are what we call like terms. Can you tell me what's 4x plus a negative 2x? Or in other words, what's 4 minus 2?
2.
2, right? So 4x plus negative 2x is going to be 2x, because 4 minus 2 is 2. And then plus 6, and then we get this. Okay? So then if we want to keep solving for x, so first we combine like terms. Now we want to use the addition property of equality. So we want to use the addition property of equality. Right? So if we want to move the 6 to the other side, if we have plus 6, what's the opposite of plus 6? What's the opposite of plus 6?
Negative 6?
Yeah, so we're going to say minus 6 on both sides. So we're going to say minus 6 and minus 6. Okay. If we do this, these go to 0. The 2x just comes down. And what's 16 minus 6?
10.
10. 16 minus 6 is 10. Then, see, we're almost done. And the time, oh, we missed 11:11, but that's okay. It was in our hearts. So the inverse operation, we want to use the multiplication property of equality. Keep in mind that division is the same as multiplication. Again, multiplication property of equality. So we're going to divide both sides by 2. And then ultimately we'll get x equals, what's 10 divided by 2, Mr. Wolverine?
10 divided by 2 equals 5.
5, right? Let's go to style, and we want this one. Okay, and then let's do a quick check to make sure that this actually works. So let's just get a copy of the original instead of rewriting it. Let's copy. I like to paste. This is fine. Let's go style. We'll do green. We'll do the darker green this time. And again, we're doing this because we would like to check. We got an answer of 5. So the question is, does that equal 4 times 5 plus 6 minus 2 times 5? Okay, let's keep it going. Out. Let's add a page. Actually, we won't need a page, but let's do it anyway.
I'm running out of paper.
Yeah, we're actually about to end. We're almost done.
I have 3 parts.
Yeah, we're almost done. Let's see. So then, let me kind of line it up actually. I'm gonna go like this. Okay. Is 16. What's 4 times 5, Mr. Wolverine?
20.
20. Plus 6. What's 2 times 5?
10.
I think that was going to, yeah. So that's going to be negative 10. What's 20 plus 6?
26.
And it was 26 minus 10.
16.
Right. And so this is correct. That confirms our result. So then we can stand by and say that x should be equal to 5. Okay, let's see. How do we do? Do we? Oh, yeah, we got it there. Let me see. What's the time? Okay. I think I'm going to leave the rest as exercise for you all. Okay. So let me close out by, go ahead, let me load a copy for everyone to access this. So I'm going to go ahead and load a copy of these notes into our shared box folder. This is spring of 2020, support for college algebra, support into the notes and the handwritten notes. So this is essentially 2.1 through 2.4. And let me actually change that in the title here. Oh, and let's get rid of this paper like that. So, and let me change this. So this is 2.1 through 2.4. Okay, enter. I want to share, send it to box, not for calculus. 2020, support, course files, into the notes, into the handwritten notes. Yeah, and we're going to export there. Okay, send to box. Oh wait, I don't really want all of those. I just want from there. And get rid of that. Okay, so if you are watching the stream or if you're watching the video, so once this bar finishes loading, you'll be able to access. You'll be able to gain a copy of the notes that you saw me doing during this presentation. If you're one of my current students in our box folder for the link on Moodle. Again, if you have any questions, just reach out to me. I have office hours. Just check the syllabus for my office hours. It should be up to date. And I've been monitoring the chat, so nobody's been asking questions. It says that I have 2 in attendance. So if there aren't, give me a second. Sorry about that. So on that note, we're going to end the session here. And from one, let's do it like this. And so on that note, we're going to end the session here. And from one beautiful mind to another, enjoy the rest of your day. Peace. You got to come like right here. Your fingers. No. Because we don't want just your here. Peace. A little bit higher. There it is. Peace. Okay.